there. It came to my attention as I was grading Lab 12 that there was some confusion about the use of standard deviation in analyzing your data. I wanted to try to give you some examples and correct that a little bit. So what I have here is just some made-up data looking at two different class periods and the data that they collected just two separate times and doing something like the PillBug Lab. So at time 1, we have repeated trials for different groups, maybe got data 5, 3, 6, 5, and 7. That gives us a mean of 5.2. And then at another time later in the trial, we got times of 10, 8, 10, 8, and 7, so with a mean of 8.6. Standard deviation on the first set of data is 1.5, and standard deviation on the second set of data there is 1.3. I'm not going to go through how to calculate the standard deviation. If that was an issue, please be sure you know how to do that. But remember, what we're doing is looking at how far each of these pieces of data is from the mean of the whole set of data, right? So we're getting a sense for how spread out the data is. So next class comes in and does the same lab, and at time 1 we get values of 4, 2, 8, 9, and 2, which gives us a mean of 5, almost exactly the same as the first class. And time 2 get data of 9, 5, 7, 10, and 10, mean of 8.2, again almost the same as the first class. But we look and we see our standard deviations are very different. This data has a standard deviation of 3.3, and this data has a standard deviation of 2.2. And you can see how much broader this data is, right? We go all the way down to 2 and up to 9, even though we still have a mean of 5. So this 3.3 versus the 1.5, showing us that this data is much more spread out. Same thing here with our data of 2.2. So what does that mean when we actually graph the data? Not very good graphs here. I didn't label anything, but just wanted you to see the points. So time 1 we have 5, time 2 we have 8, and I drew in the standard deviation bars here. So I'm going up and down 1 standard deviation. So for this one, that was 1.5, and for this one, that was 1.3. A big mistake I saw seemed that these standard deviation bars were all the same, and I wasn't sure where those were coming from. Each data point that you're graphing is a mean. So that mean has a standard deviation associated with it that you got from how close that all the data was clustered around that mean. This data was fairly close to that mean, small standard deviation. This data was spread fairly widely from that mean, large standard deviation. So when we look at that second class set of data, we're going up and down 3.3 each way here and 2.2 each way here. So what does this mean? We have the same data points, roughly 5 and 8, but here when we look at these bars, we're seeing that they don't overlap. So we can be confident in saying that this value of 5 is significantly different from this value of 8. We did have a change here from 5 to 8. We do have an upward trend. In this case, since there's such an overlap here, we can't say with any confidence that we wouldn't have gotten, if we did it again, these 2 points might really be the same. We didn't get data that really confidently tells us that we got something different at time 2 than what we got at time 1. So we would say that this first set of data was valid and we would use it to draw a conclusion. But the second set of data is invalid. We cannot use it to draw a conclusion. And that was another error I saw repeated over and over again, was that people would say, yes, we saw an upward trend. Our hypothesis was right. Oh, but by the way, the data was invalid. If your data is invalid, you cannot use it to draw a conclusion, and that's okay. Just say that. I hope this helps, and I'll see you in class.